Hi to all. How are you, children? How is your preparation? And now I am going to continue the motion in a straight line for the 9th and 11th class. And it will be uniform up to one more lecture, and later the 9th class chapter will be complete, and the next 11th there is some more extension will be there for the motion in a straight line that I will continue. Okay, now let us start. And now the next topic, in the last topic we discussed about the displacement, distance, speed, velocity, acceleration. These terms we discussed, and now I am going to continue my class. And now the first I am going to explain some graphs. Okay, now first I am going to explain the graphs. There are different types of graphs are there. First, position time graph I am going to explain. Position time graph. Position time graph. Position time graph, how it will be there, and what is the significance of the position time graph, that I will tell. Okay, and now position time graph for the rest body I am going to draw. For the rest body, position time graph. In the 8th class you learned how to draw the graph and what is a graph. And first rest body I am going to draw the position time graph. For that, the position I will take on y-axis. Position I will take as on y-axis, and the time on I will take as x-axis. Okay, x is the position and t is the time. I am going to draw the graph for the rest body. Okay, and for this is x-axis and this is y-axis. This is origin, you know that one. And how to draw the position time graph for the rest body. For this, for example, this is the coordinate system. Okay, coordinate system 2D means two axes are there that are perpendicular to each other. For example, this is the 2 meter location or the 3 meter location. This is 6 meter location. For example, one person is standing at the 3 meter location, right? Okay, this is 6 meter location. This is the road. Okay, on this there is some board is there here, 3 meter, 6 meter, 9 meter, like this increases. One person is standing at the 3 meter. Now if we take the some time values and position value, starting time that person is at 3 meter. After 1 second also time becomes 1 second. Again the person is at 3 meter. After 2 seconds also the person is at 3 meter. Position is always 3 meter. After 3 seconds also person is at 3 meters. After 4 seconds also time is increasing 0 to 1, 2, 3, 4 seconds. But the position is not changing, 3 meter, 3 meter, 3 meter, 3 meter. That means position is not changing. If the position of body does not changes with the time, then that body is said to be at a rest, right? And now how to draw these values? Okay, this is x, y, x 0, y 3 meters, right? Time on x-axis, time on x-axis, and position on y-axis. X comma y is a point. How to denote? Okay, this on x on the coordinate system. This is x-axis and this is y-axis. Okay, and now first x means x distance we have to take, x distance, and y is the y distance, right? And this point will be like this, it will be there. This is the x comma y point, right? Okay, and now this distance is y and this distance is x, because it is forms a rectangle, opposite sides are equal. What we have to do here? First check time as 0. 0 is this one, origin, and x is the 3 meter. For example, this is the 3 meter location. This is the 3 meter location. Then 0 comma 3, where it is? Here it is will be there. Right, this is the point. After 1 second, for example, this is 1 second. Okay, this is 1 second. Time is 1 second. Time 1. Okay. Then after 1 second, what is the position? Again 3 meters, 1 comma 3. After 2 seconds, for example, this is time 2. 2 comma 3. 4 comma 3. Right? Then we will get the points like this. And then if you join the we will get a straight line, right? And now the rest body, for the rest body, the graph we will get, position time graph we will get like this. Okay, and what is this? What is the nature of the graph? The graph is a straight line parallel to x-axis, right? Graph is a nature of the graph. What is the nature of graph? Okay, graph, we got a straight line. Straight line means linear, right? Graph is a straight line. Straight line parallel to, right? Parallel to x-axis. This x-axis we also say that time axis, because we are taking the time on x-axis, that's why time axis. Okay, position on y-axis. This is the graph for the rest body. Very simple. It is position is constant, means straight line, right? And now the second one is that I am going to draw the graph for the uniform motion. Uniform motion or the uniform speed. Uniform speed. When we say that a object is in uniform speed or uniform motion. Okay, uniform motion or uniform speed. Then the uniform speed means the speed should be constant, right? What is the formula for the speed? Speed is equal to distance by time, right? Now speed should be constant means, when the speed will be constant, tell me? If distance and time, if both are constant, then the speed will be constant. If distance and time constant, then speed also constant. If speed constant, then we say that that object is in uniform motion. Okay, uniform motion or uniform speed. Then for that, what we have to do, right? Object should travel equal distances in equal intervals of time. Okay, if any object, if any body travel equal distances in equal intervals of time, in equal intervals of time, then the body is said to be in uniform motion, right? Or uniform speed. What should be there, right? If your body covers equal distances in equal intervals of time, then that body is said to be in uniform motion. Equal distances, equal times. Distance equal, time equal, then the speed is equal. Speed is constant, right? The speed should be constant. That means distance should be constant, time should be constant. How it will be there? One example I will tell, right? For the uniform motion. Look at here. Let us see here. First, I am going to take the time on x-axis and the position on y-axis. Time 0 second and 2 second, 3 second, 4 second, 0. Let us consider 4 seconds. Next 6 seconds, 8 seconds and 10 seconds. And now the position values. Okay, the position. For example, one car is moving on the x-axis. One car is moving on the x-axis, right? One car is moving on the x-axis. It starts from origin at t equal 0 seconds. It does not travel any distance. The position we can take as 0. Position we will take as 0. This is the 0 meter position at a time t equal to 0 seconds. After some time its position changed. Now the new position is x is equal to 5 meters, right? this is the location after 2 seconds. After 2 seconds it is at 5 meter location, means how much distance traveled? 5 meters traveled. And the next, after some time, this is the location. Now at 4 seconds, the distance, it is at a location, it is at location 10 meter distance. Okay, and after some more time, this is the time 6 seconds, and now its location is 15 meters, right? It is at 15 meter position. Okay, look at here, what happening? This distance is 5 meters, right? And this distance is 10 meters, and this distance is 15 meters. Now here, how much distance it is covered? 5 meter distance covered. How many seconds required here from here to here? 2 seconds required, right? In these 2 seconds, 5 meter distance traveled. This is also 5 meters from here to here, because this is 5 meter position, 10 meter position. This distance is 5 meters, and this distance is also 5 meters. The total is 15 meters, right? The total is 15 meters. This is the total, right? And now look at here, what happening in this. Try to understand the concept. Now what happening at here? Okay, look at here. The body, in the first 2 seconds it travel from 0 meter to 5 meter. That means it travel 5 meter distance. In the next 2 seconds, how much distance it traveled? 5 to 10 means again 5 meters. In the next 2 seconds, right? 4 to 6 means 2 seconds gap. In that 2 seconds gap, how much distance it travel? 10 to 15 means how much distance? 15 meters, 5 meters it is traveled. That means what happening at here? Equal distance, 5 meter, 5 meter, 5 meter. Equal intervals of time, 2 second, 2 second, 2 second. Right? If a body covers equal distances in equal intervals of time, then that body is said to be in uniform motion, right? Or the uniform speed. Okay? If you find out the speed at here, the distance is what? 5 by 2. Distance is 5. Time is 2. 5 by 2, 2.5. Here the distance is, for this interval, 5, time 2. Again the distance 5, time 2. Distance of time always the same, means speed always same. That means this object is moving, this car is moving with uniform speed. And now for this, how the graph will be there? What about the position values? Tell me. Starting at 0 second, the car is at 0 meter position. Right? After 2 seconds, the car is at 5 meter position. After 4 seconds, it is at 10 meter position. After 6 seconds, it is at 15 meter position. Right? For every 2 seconds, the position is increased by 5 meters. Then this will be 20 meter position. This will be 25 meter position. Now, based on this, by taking these values, if you draw the graph, how it will be there? Let us see how it will be there. But we have to do it here. Then the time we have to take on x-axis, right? The time is t. And now the position values we have to take on y-axis. What is the position? Position is x, right? Position values we have to take on y-axis. Position is x. Now how the graph will be there? The time this point is 0 second. The position values we may take is 0 meter and 5 meter and next 10 meter, next 15 meter, next 20 meters. These are the position values. Okay, time we will take is 2 seconds and 4 seconds and 6 seconds and 8 seconds. Okay, now what happened? First 0 comma 0 means origin, and next 2 comma 5 it will be at here at the 2 comma 5, x2 y5. x2 means 2 here there, y5 means here at there, then x2 y5. This is the 2 comma 5, right? And the next 4 comma 10, right? This is the 4 comma 10. Okay, and next 6 comma 15. Right, like this we are getting. If you join these all things, How we are getting the graph? We are getting the graph a straight line, right? We are getting the graph a straight line. This is the position time graph. The xt graph, how you got? Tell me. This is the t and this is x. How you got? It is a straight line, right? It is a straight line. This is the position time graph for uniform motion. Position time graph for uniform motion is a straight line that is passes through the origin. Okay, that is passes through the origin. And the next, I am going to explain the non-uniform motion. First rest uniform motion and next non-uniform motion. Now let us see position time graph for the non-uniform motion. Now first non-uniform motion, C point. C is what? Non-uniform motion. Non-uniform motion. Okay? Non-uniform motion. In non-uniform motion, we will get the graph like this. Okay? And what is non-uniform motion or non-uniform speed? Okay? First we have to define the non-uniform speed. Non-uniform motion or the non-uniform speed. Uniform means speed constant. Non-uniform means speed changes. In reality, the vehicles will move, bike moves or anything moves. That its speed is not constant. It will not go with uniform speed. Its speed is changes. Okay? And when we accelerate, the speed will increases. When we apply the brakes, right? When we down the gear and when we apply the brakes and when we down the accelerator, at that moment what happens? The speed is decreases. The speed is variable, right? Always we cannot go the vehicle with the same speed, right? Its speed is changes. In the reality, most of the vehicles will go with non-uniform speed. That means the speed is not constant. Speed is a variable. Okay, speed is not constant. Speed changes with the time. Okay. Then what? When the speed changes. Okay. For example, in the first 2 seconds, it travel 5 meters. Next 2 seconds, it travel 15 meters. In the first 2 seconds, it travel only 5 meters. In the next 2 seconds, it travel 15 meters. That means whether the speed is increased or decreased. In the first 2 seconds, it travel 5 meters. In the next 2 seconds, it travel 15 meters. Means the speed is automatically increased. Right? Because in the less time, it is traveling more distance. In the second case. In the first 2 seconds, it travel only 5 meters. But in the next 2 seconds, it travel 15 meters. Means it is travel long distance. Right? Okay. Long distance it travel means its speed is increased. And now, in this case, if a body covers, here distance is, if time constant, we take the time constant and the distance changes. Okay, speed is variable. Speed is variable. Okay, look at here. When the speed is variable, how to define this? If a body covers, if a body travels, unequal distances in equal intervals of time, okay, then that body is said to be in non-uniform motion. Okay, here what happening? Equal distances, equal time means uniform speed. Unequal distances in equal time, that is non-uniform motion. Okay, remember that. Okay, we should not say unequal distance in unequal intervals of time. We have to say unequal distances in equal intervals of time. First 2 seconds 10 meters, next 2 seconds 15 meters, next 2 seconds 20 meters. Okay, here first 2 seconds 5 meters, second 2 seconds 5 meters, next third 2 seconds 5 meters, means always equal time equal distance, equal time equal distance, and equal time unequal distances means that is non-uniform motion. How the graph will be there, right? Position time graph. Let us see here. The graph like this it will be there. The position is taken on x-axis and the time is taken on y-axis. The graph we will get a curve. Okay, we will get like this. Okay, this graph is a nature of the graph is curve. Curve or parabola. It's also said to be, this shape is also said to be parabola. Parabola. Okay, and now in this case what happening at here, and now you may get like this. Okay, the graph you may get like this, or otherwise you may get the graph like this. This graph indicates that it will move with the uniform acceleration. Okay, its velocity is increases with the time, and it is said to be uniform acceleration. Uniform acceleration. We can also say that this graph is for acceleration. Here the speed is changing, means velocity changing. Speed is not constant, means changes. Speed changes means it has some acceleration, right? And uniform acceleration. That means acceleration is increasing. Here the velocity is increasing, speed is increasing. Velocity increasing uniformly. Velocity increases it here. Okay? And now if the graph we will get like this. Okay, and now this is the x and this is the t. This graph, it is also nature parabola, right, or curve, and this graph indicates uniform retardation. Retardation means what? Negative acceleration. Negative acceleration means speed or velocity. Here the speed or velocity. Why I am telling the speed or velocity? Because we are discussing the motion in a straight line. In a straight line, in one direction the speed or velocity two are equal. Decreases it here. The speed or velocity decreases. Right? And this graph indicates that one. This graph. Okay? And for this graph. And now this is about rest. We drawn the graph for position time graph for the rest body, uniform motion and non-uniform motion. Now what is the significance of these graphs? Is there any use with these graphs? Okay, and let us see, and how we are telling that its speed is increasing and how we are telling the speed is decreasing. Okay, let us see here. And here the speed is constant. In this case the nature of the graph is what? In this case the nature is, just tell me nature, straight line, right? Straight line. And this indicates speed is constant, velocity is constant. Okay, uniform speed na? That means v is constant. When v is constant, what is its acceleration? Acceleration is 0 in this case, because velocity constant means acceleration is 0, because acceleration formula is change in velocity by time. When velocities are constant, the change in velocity is 0, then acceleration is 0. In this case, this is for 0 acceleration, this is for positive acceleration, this is for negative acceleration. I will explain more and you will understood clearly, right? And okay, or otherwise for the 9th class student only you require the shapes, and for the rest body what is the shape, and for the uniform motion body what is the shape, and for the non-uniform motion body what is the shape. Okay, right. Let us see. And if an object is thrown vertically upward, what happens? The graph, okay, xt graph for a body thrown vertically upward from the ground. For that, how the position time graph will be there? Okay, right. Then what happening when we throw any object upward? Its speed, what happens? Velocity. If you throw upward, the velocity decrease. After reaching highest point, its velocity becomes 0. If its velocity not 0, then it will go further upward. When we go upward, velocity decrease. When it reaches the some point, its velocity becomes 0. But due to gravity, again it will come down. When it will come down, its speed is increases. That means while going upward, velocity decreases. While going downward, velocity increases. Look at here. This is velocity decreases graph, and then this is velocity increases graph. We will get the graph like this, the position time graph. This is the graph between the position and time in case of what? This is the time graph, and this is the position time graph for the vertically upward projected body. Here this indicates velocity decreases, and this indicates velocity increases. What is this? Let us see here. Let us try to understand these things. Okay, and now significance of position time graph. Significance. If you know significance, some more details will about the position time graphs, right? For the simply also we can tell this graph here, the position time graph for the rest part like this, for the uniform motion straight line, for the non-uniform motion curve. This is also non-uniform motion, right now? Why non-uniform motion? While going upward, speed is decreasing. While coming downward, speed is increasing. Means speed is changing. Means it is non-uniform motion. Okay, right. And the significance, for example, this is a position time graph. This is the position, and this is the time, and this is the graph. For example, this is a graph. We are taking the 2 points on the graph. One is A and other one is B, and we draw one horizontal line, okay, and vertical lines. This will indicate 2 points on y-axis, x1 and x2. This will indicate 2 points on x-axis. Time it is there, t1 and t2. There is one formula is there in the mathematics. The slope. Okay, slope of graph. Slope of xt graph. I want to find out. Then what is the formula for the slope of xt graph? The slope is equal to difference in y coordinate by difference in x coordinate. You remember the slope formula. Difference in y coordinate different, x2 minus x1. X coordinate different, x coordinate is time difference, t2 minus t1. What it is indicating? The slope of xt graph indicates velocity, right? Why? This is change in position by time. Change in position by time is a velocity. Here slope of xt graph indicates the velocity or average velocity. Okay, velocity or average velocity. The slope indicates the average velocity. And there is one more formula is there for the slope. That is the slope formula in the mathematics. It is there. That is the slope formula is tan theta also. The slope formula is tan theta. There is one more formula. Okay, you can take the screenshot and note it. Let us continue. The slope is equal to, the slope, one more formula is tan theta. Okay, what is tan theta? You will in the mathematics you will learn theta is angle. For example, this is a triangle, okay, and this is angle is theta, and this is x, this distance, and this is y. Okay, for example, on y axis the difference, this is delta y and this is delta x. Okay, and then the tan theta, there is a one formula is there. Tan theta is equal to opposite side by y axis, difference in y axis, opposite side, theta opposite side, angle opposite side this one, by angle adjacent side this one, delta y by delta x. Okay, you will learn clearly in 10th class maths. In trigonometry one chapter will be there. Just now you remember tan theta formula is delta y by delta x. Here delta y by delta x, here also see delta y, difference in y coordinate, this is the delta y. Here we can form the triangulate here, like this is the theta, right? This is the theta. Okay, and now if theta is, slope is equal to tan theta equal to delta y by delta x, opposite side by adjacent side, and this triangle if you draw it here, okay, and how you will get? Here we got the position time graph. The time is on x-axis, position is on y-axis. This is the graph. We are taking the 2 points on the graph, right? 2 points we are taking on the graph, A and B. And now we will draw the horizontal line at here, A, and this is B. And this position is x1 and this is x2. And the next, this one is T1 and this one is T2. Let us see here. We can draw one triangulate here. Okay, we can draw one triangulate here like this. This is one triangle. Okay, and this angle is we can take as theta. Theta is how to find out the theta? This distance is what? How you will get this distance? For example, this is 2 meter and this is 5 meter. This distance is 3 meter, right? When we have to subtract these two, this distance is x2 minus x1, right? x2 minus x1, and this distance if you want, okay, this distance you want, that is t2 minus t1, we have to subtract these two, right? What you are getting it here, the slope formula, previously I said the slope formula, theta is what at here in this, theta is angle made by straight line with x-axis, right? That graph is making some angle with x-axis, that is theta. What you are getting the tan theta here, tan theta formula is what? Opposite side by adjacent side, delta y by delta x in the triangle. What is delta y in this? Opposite side minus x1. Then what is x2 minus x1 at here? x2 minus x1 by, okay, this is adjacent side, tan theta formula is delta y by delta x. Delta y is x2 minus x1. Delta x is t2 minus t1, right? And this is t2 minus t1. And this is the displacement and this is the time. Displacement by time gives velocity. That means the slope is equal to tan theta is equal to velocity, right? Tan theta is velocity. The slope of position time graph indicates the velocity or average velocity, right? Then velocity, when it will be possible? Velocity is equal, we are taking formula is tan theta, right? Velocity is tan theta. If theta is positive, when we say that theta is positive, you remember that if theta positive means tan theta positive. When tan theta positive, then the velocity is positive. Velocity positive. Okay. If theta negative means tan theta negative, that means velocity is negative. Velocity negative means opposite direction it is coming. Okay. When the theta is positive and when the theta is negative, for example, this is a graph like this is x-axis, and if it is there like this is a graph like this, it is there, this is theta. Anti-clockwise angle, okay, anti-clockwise angle we will take as positive. this theta we will take as positive. Anti-clockwise angle we will take as positive. For example, the same graph it will be there like this. This is the graph. Okay, like this it is there. Now let us see, the graph is like this there. Angle made by the x-axis theta is downward, it is there. Okay, or otherwise we will take like this. This is the graph. We got the graph like this. This is the theta. Okay, this is x-axis and this is y-axis. And now anti-clockwise angle we have to take as this side downward is a clockwise angle. Clockwise angle we will take as negative. Okay, now this is simply the significance is that in one word the significance is that the slope of position time graph indicates the velocity. If you find out the slope, then we will get the velocity. If you find out the slope, then the velocity you will get. Then previously one time I will tell, in this if you throw the object upward, the velocity is decreasing it here. Okay, if you got like this, I said this graph is, in this case the velocity is increasing. I am telling velocity is increasing. This is velocity increases. How velocity increases here? For example, here we will take the angle. Okay, theta we will get like this. For example, here x-axis, this is x-axis, we will draw here parallel line, and here you take the angle, this is theta, but here to here you can compare. This angle is small, this angle is more. That means theta is increasing, right? When theta is increases, here you take, and this is the theta. That means what happening at here, the theta is increasing. When theta is increases, then the tan theta is increases. Tan theta increases. But what tan theta says? The tan theta says the velocity, right? Slope is equal to tan theta. Tan theta we got according to this formula, opposite side by adjacent side, that we got velocity. That means when theta increases, velocity increases. Right? This graph shows that velocity is increasing. Velocity increasing means non-uniform motion, right? Non-uniform motion. And here, if the graph is like this there, right? And here angle is theta, and here you take the angle, this theta, and here you take the angle theta. What happening it here? Theta is decreasing, is it right? Here to here, the theta is decreasing. Theta decreasing means velocity decreases, right? Velocity decreases means it is negative acceleration. Here velocity increases means it is positive acceleration, right? Have you understood now? Okay, thank you for watching my lectures. If you have any doubt, you can consult me in my WhatsApp number, or you can comment. Okay, thank you for watching my lectures, and compulsory you can like my channel, press the like button and share to your friends. Subscribe my channel. Thank you for watching my lectures.